Hello there. So this is our tutorial. In this our second tutorials, we are gonna to discuss about the selection sort. So in our previous video, we have completed array and we have completed our bubble sort. So now we are gonna to start with the selection sort. That will be the next topic of our data extraction algorithm. So now we can move to our theoretical part first. We will cover it, then we will move to the our applications and we will start with some demo. We will do some program, so it will make you more clear. So now let's start with our theory for the selection sort. So basically in the selection sort, suppose we have elements in this array. Let's assume that one, this is our elements, and we in our previous tutorials we already discussed it. We have a blocks of memory which is occupied in our locations or memories, and in these particular elements which is we have defined, that occupy the same amount of space in the memory. So now let's consider we have some elements like 11, 14, 15, suppose 17, 90, 101, 52, 75, 80, like that we have elements in our array. Now so in selection sort, what selection sort tell us? First you have to take this element, okay, and our first elements we will consider this is the largest element in our array. This will be the largest element in our array. Now if it is the largest element, we will consider first this is my largest element in the array, and we will start the iterating. So first we'll consider this is our elements which is the largest element. We will consider 11 is greater than 14. No, 11 is not greater than 14. Then I will change this largest element to the 14. So now my largest element will be the 14 at the first position. As we know that in array we indexes start from the 0, right? 0, 1, 2, 3, 4, 5, 6, 7 and 8. Total 8s we have. So first we will consider 0th positions, the elements what we have, that is the highest long value in our array we considered. Now we start the iterating and we will find is 11 is greater than 14. No, then my largest element will be the 14 now, which is at positions 1. Now I will compare 14 is greater than 15. No, 14 is not greater than 15. Then my largest element will be the 15, that is the position of 2. Now 15 is greater than 17. No, 15 is not greater than 17. Then my largest element is going to be replaced by 17, and this is positions of 3. Then now what will happen next? I will compare the 17 is greater than 19. No, it's not greater than 19. Then what I can do? I will replace this one again with a 19. So at fourth positions, index fourth positions, by a fourth 90 element has been updated, and currently my largest elements become a 19. We started from the 0, right, and we move from 0 to 1, 1 to 2, 2 to 3, and we reached to the fourth position. But now we found that no, 90s is a greater. Now you can see the one sort here in the one loop, actually the one iterations we reached till here, and we found our 19 is the largest element in the array. Now I will consider, and I am going to check 90 is greater than 101. No, then my largest element become replaced by the 101, which is as position 5th. Okay, now after that I will say 101 is greater than 57. No, 100 is yes, 101 is greater than 57. I will not replace it. 100 is greater than 75. Yes, 101 is greater than 75. I won't replace it. Now 80 is greater than 101. No, it is not greater than 101. So our largest element will be continue with the 101. Okay, so it will be the came to the their first position. Now in the first iterations, when iteration will be moved, my first elements 101, it will reach to the correct positions. That is the from left to right we are moving. Sorry, here we are moving from left to right, and my 101 has reached to the next highest positions of the index, that is a position of 8. Now it is reached to the 101. So we, our first element has been cover up, our first element 101 has been occupied these locations, and our 81 will come to these positions. Okay, so let me explain one more time how can I clean and show you again, so that it will not for this one same color only. No, okay. So suppose now this 90 is there, right? So our 90s will move to the location at 8th positions, and our 80 will come to the this position. Okay. Now next time what will happen? This is the first iteration. Is the first loop it started. Now in the second loop, again I will take 11 is greater than 14. 14. No. Then for this will be the first. This elements I will put in the largest elements. Again I will check one is what is the position of index at 1, it is greater than this one. No, yes it is. No, so it's not a greater than, that is 15 is a greater than. Then I will replace our largest again with the 15th. 14th will replace by the 15th. Again I will see the 17th. Yes, 17th is greater than 15th, I will replace it. Now you can see here it was before, I think I written 90 here. So yeah, 90s is greater than 17, yes it will replace it. Now you can see here is a 90, here is a 80 after replacing, right? So what will happen once after replacement it will happen. Now 101 will be here and 80 will be here. So it will again, it will not swap because 90 is greater than 80. 90 is greater than 57, yes 90 is no, no replacement. 90 is greater than 75, yes 90 is greater than 7, and it reached to the positions of this. That means one less than, because first iteration is already completed, so one loop is already over. Now in the second loop its number will be less than 1. So what will happen, it will come till 7 only. And now this 80th 90th position which is coming is going to be replaced with the 75. So this 75, instead of 75 it become a 90, and this position is replaced by the 75. So this is a selection sort. Selection sort in the sense is nothing but we select one elements, will compare from 0 till the end of this array, till of the end of the index of the array. First iteration will complete. In the second iteration what will happen, it will start and it will go to the n minus 1, again n minus 2, again next iteration n minus 3, and again n minus 4, again iteration n minus ith elements. Like that it will be moved. So this is the basically theory of the selection sort. Now let's go, we will implement this one and we will see how selection sort looks in the program and how efficient is. So now let's move to our the program. So now let's move to our IntelliJ, as we work like that, first theory then we write the practical. So now we are going to our IntelliJ. Okay, now in IntelliJ yesterday we had a course. Last video we discussed about array and we discussed about this bubble sort. Now we are going to discuss about the selection sort. So I will create one class selection sort. Okay, now my class is ready. So just I want to tell one more thing. So selection sort is very much similar to the bubble sort. Only thing in the bubble sort we are just comparing to the next elements. In our previous tutorial how we have discussed and see the program. So in the bubble sort we had comparing to the next elements and we are moving. In bubble sort also we are moving from the left to right. Same thing will going to be happen in the selection sort also, it will move from the left to right. But the only thing is that here we will collect or take one element, that is the first element we will start our iteration, we will consider as the largest element, and as per that largest element only we will move from the left to right side. Okay, so it is very much similar to the bubble sort. The person who know this my videos, who seen my last video where bubble sort has been implemented with the theory, they don't have anything about the selection sort. It's a very simple, very similar to that bubble sort only. So it's going to be almost same. So now let's start with the selection sort. This is my main method. So basically we will declare our one array here, suppose int array. Okay, now we will create array, suppose 20 minus 67, 9, 54, 54, 8, 109, 30, 70. So let's consider this is our elements, array elements. Now yesterday I told you, right? So whenever you are going for the interview or you are preparing or you have working on any applications, definitely you are getting this type of such data either through the your database which is already have, or through the any API call, REST or SOAP, or any third party microservices. From there you are getting, and you have to sort it and you have to filter it out, you have to find it, an element is available or not. So these all things you can do very easy, and this is the way you can achieve that one. Okay, so you have to just think in such a way also, so that your preparations will also be good in that case. Now you can see here I have an array, okay, and I have the this much of elements what I have declared as a total 8 elements I have declared. So now we are going to start our the program. So what we can do, we will write the one for loop int last unsorted element, sorted index. So here we will consider the length of that one. Okay, so this is our length. Okay, -1, last element is greater than 0. Okay, last element minus. Okay. So this is just very simple. So as I explained you here, just let me come to this here. Okay, so I just in the theory I have told, right, key when you will move from the left to right, so right, so that's why I have declared the elements like a last sorted element. So I'm considering this is a last unsorted element, so that's a variable I have declared as a last unsorted elements, okay, or index. So this is I am considering as a last unsorted, and this one I am considering as a the largest element. Okay, so don't be confused here, it's a very simple. First I am considering this is element is the my largest element, and this is the last element which is at the positions of the last index. It is the unsorted elements I am considering, and I am considering this is the largest. I have to move from here to here, right? I have to move from the first to last, but I have to check which is the more largest, so those elements will come in the last index positions. Okay, so that's why I have given the variable name, so that similar, so that it will be a very meaningful. So don't be confused here. Okay, now let's come to our IntelliJ here. Okay, so this is now ready. So what I will do here, I will declare one, sorry, int largest. Okay, and the case of GWith position. So what I'm considering here, in these positions the elements which has been declared, right? So as I told you during my theory, I am considering this is the largest element. Suppose I am considering this is the more than 889. You can see here in this array maximum highest number what I have chosen is 889, right? So now let's consider 2000. So this is the I am considering this is a 2000, and it's the highest position 0, and is the highest element. So unsorted index I have given, right? So that I have given this location which is unsorted, and I have to move from these positions to these positions. Okay, so very simple, and I have given a meaningful name, so it won't be a confusing for anyone. Now let's start with our for loop int I. Let's consider as a 1, I less than or equal to, you can consider the last. So okay, and I plus you have to keep it. Okay, very simple. Now till here everything is fine. I don't think there is any confusion. Okay, do you have any doubt, any questions, please you can write in the chat and there in the channel, so that I can reply to you. Okay, so there is still here, I don't think any questions should be there. Okay, because it's so simple and very straightforward things. Now let's format it. Okay, that's fine. Okay, now the thing is what I need to do, if now, so what is the conditions here, what I have told you in these scenarios, I will check this element to this. Let me first erase this one, so that we can it's make little bit clear. Where is the, it is signature. No. So what I told you here in this program I am writing, I have to write the criteria, conditions. If you have seen my last video, in last video I explained you in the bubble sort we are sorting, checking the first to the second, right? First is a greater than second or not, right? But in the selection sort we are writing or considering first element is the largest element and as taking the reference of that, and we are proceeding from the left to right till the end of the indexes, either or you can say the last of the indexes. Okay, so if you can see here, if I, why I'm showing this again and again, because I'm going to write the conditions here. Okay, so what the conditions we are going to write it here, we are going to consider this value, right? And we have to come check these values, right? And we check if it is greater than this one, then we have to largest to increase by this particular index positions. Okay, that's why I have written that one. Now I'm going to write this one int array, sorry, int array, if int array at I is greater than int array at largest. Okay, fine. Now I will make as a largest equal to I. So simple here. Okay, now this is done here. Okay, now this has been done here. So now we will write this one method to swap this element, right? So we will write one static method here. Void simple one method, like simple same will be happen like a bubble sort what we had in our last tutorial. Int array, let's consider same as the int array, so not be confused. Int array. Okay, I will make mark as I will mark as a J here. Okay, so in these elements, if I equal to, now what we have to do it, if I equal to J, okay, what we need to do, we have to return it, that's all, right? Return, or else if it is not there, then we are going to swap it, right? So int, I will make some temporary variable. Okay, int array, int array at I. Okay, now int at I will put the value of int array of J. Okay, and in case of int array of J, I will put int array of I. Okay, so simple. It will, no, sorry, it will come to you this part, not it's because I is already replaced by J, so no useful. Okay, now done. So you can see here what I'm doing, I have getting this data, it's maybe from database or from the backend, from the service side, from the microservices, or from any REST API, any web services, whatever. Now we are going to sort it. We have unsorted, last unsorted index, which it's nothing but this one, and this will be the my largest limits I'm considering, that's why I have mentioned as the largest is 0 position. Now I will see the at index int array at I 0 position, this one I'm considering is greater than this one, then we can mark it. If it is not, then let them go ahead. Okay, and this will be keep on going, and after then we are very much sorted positions when we leave, this loop is going to be completed, right? Now after then what we have to do it here, once it will 4 is completed, then we have to sort that one. swap it, int array, comma, here you have to pass the largest element, so here you pass to the last unsorted, that's all right. Okay, so when it will complete it, then we will try to print and see the values equal to 0. Int array, int array dot length, okay, dot length, then I plus plus. So simple. Now it is just like a printing, nothing fancy is here, so I can do it here. Sorted element, okay. So if it is sorted element, then we will see how this looks like, my sorted element after sorting. And that's all. See, so simple our selection sort. Now it has been completed, and now I'm going to execute it, and let's see. Now you can see here minus 67th, that is the most least value in this array. After then 17, 20, 30, 99, 109, 334, 99, 889. Total 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 elements. You can know it has been sorted. So this is all about the selection sort, and I hope everyone, it's a very simple way I have explained you. So assuming there is no confusion should be, I mean, considered here, and it will be so simple. So please let me know if you have any doubt on this one, or you want to any discussions or any questions. Please drop me a text, I will reply back to you surely. So this all about this selection sort. We have completed our selection sort. So thanks for watching this video. If you like this video, please like and subscribe, so that whenever my next video will come, you can get a notification for the same. Thank you so much. Have a nice day. Bye.